preview. Now, a couple of things to make mention of here, especially at the top with the factoring, since this looks like it's about a third of the quiz. You won't have this, of course, written for you somewhere tomorrow, but just a couple of things to remember when you're going to go and start factoring. Okay, there's always kind of a two-step process to this. Okay. My first question's always got to be to myself, is there a greatest common factor? Is there something I can take out? Whether it's a number, a variable, maybe both. Because a lot of times that'll make it easier in some ways, or it might trigger something and be like, oh yeah, that's what I have to do with that now. Once I get that taken care of, my second step is looking at how many terms there are, because that's going to be my next big clue. So in this case, if there's only 2 terms, that's probably going to be something to do with either squares or cubes. So like number 1, number 3, number 4 down below, I'll only have 2 terms. So I want to start looking, do I see perfect squares? Do I see perfect cubes? Because that might trigger something with me. If there's 3 terms, like number 2 and number 5, I'm either going to be looking at the diamond or maybe I'm going to be looking at slide and divide. Again, I can only do the diamond if that coefficient, if that number in front of my x squared is 1. Like number 5, I could do a diamond on. Number 2, we'll talk about that when we get there. And then our only other one we've been doing here is 4 terms. And that's when I'm doing the grouping, when I pair them off and just pull the greatest common factor out. Again, that's something with practice that you're going to get more of a hang of. So if you've been procrastinating on the factoring sheet, hopefully that's something that will help that to make it a little bit easier. How's that going to help us now? Well, for this first group, okay, so 1 through 6, again, I look, and nothing comes out of 9 and 100, but it's 2 terms, and they both look like perfect squares. Again, your perfect squares, you need to know them up to 10. Cubes, you need to have a feeling up to 6. Now, if that means when you get your quiz, you quick do on the calculator and make yourself a list at the top, that's fine. But again, that's taking up some time. So here, what do I square to get each of my terms that I see? 3x to get 9x squared. What about 110? Plus and minus. Okay, that one's done. That's the one thing we've got to be careful of, because some of you are into a mode where you're trying to over-factor things. And it's not always going to go with all of them. Those aren't perfect squares. I don't see squares. I'm done. Anything in common on number 2? Okay, I take a 4 out. That just made life easier. I could have done slide and divide on this. But again, the number's going to get kind of big. I'd have had to multiply to negative 256 and add to negative 24. I don't want to mess with all that. If I'd taken the 4 out, now I can do a diamond on this. So what multiplies to get negative 16, but adds to get negative 6? Okay, negative 8 and 2. And again, once I do that, no more squares or anything else. I'm done. It is. It's just a process we've got to keep working at. Here, I see there's nothing I can take out. I see it's only 2 terms, and I see the cube there, so that's kind of a hint. But remember, when you go to do this one, what do I cube to get each of those parts of x cubed plus 27? Okay, x and 3. Once I know that, here comes that form again. So just to kind of remind you, and again, it changes whether this is plus or minus. The one for plus, here's what my form looks like, and then we'll actually fill that in here. The only difference is, if it were a difference, if it were minus instead of plus, these two things would switch. Otherwise, it's the same. So when I go to write this, I'm like, okay, so I'm just going to add my 2 terms. So x plus 3 Then let's see. Square my first term. My first term is x, so that's x squared. That's always going to be a minus. Multiply the two terms together, and then square my last term. The nice thing about the cubes, they're always done at that point. I'm finished. But you've got to know the form. The form will not be written for you on the quiz. You have to have a little idea of that, or if you need to, kind of get it into your head, and as soon as you get your quiz, write it down real quick. Scooch this a little bit. So I look again, two terms, nothing in common I can pull out. Squares or cubes? Ooh, squares. What do I square to get each of those? Okay, x and 8 is a y this time. And again, it's the difference of squares, which means it's going to be plus minus. No other squared terms, okay? If I don't see x squared or y squared anymore, I'm not going to be able to factor anymore. That one's done. The biggest thing in here is to be not over factor. Alright, so like, okay, nothing in common. Ooh, x to the 4th. Wait a minute. Okay, we're going to treat this just like it's x squared plus x minus 56. It's still a diamond. There's no number in front of my first term. Don't let the 4 fool you. I need two numbers that multiply to negative 56, but add up to 1. Okay? Let's say they have to be real close. So 8 and 7. Since I want it to be positive 1, the bigger number's got to be positive. But here's the twist. What goes in first in each of my parentheses? X squared, because x squared times x squared is x to the 4th. And if I FOILed this out, 8x squared minus 7x squared is 1x squared. I can't go any further. Now, if this would have been x squared minus 4 or x squared minus 9, then I could break it down again. But in this case, I don't have any perfect squares, so I'm kind of done. Again, it's like anything else. It's like playing an instrument, getting good at a sport, fixing cars. The more practice you get, the easier it's going to become, and the more second nature it will be. If I see 4 terms, that automatically goes to grouping. So in my first set of parentheses, what have we got in common? 3x squared. So just in that first set then, what do I need to get from 3x squared to 3x to the 3rd? Just x, okay? What about to get from 3x squared to negative 15x squared? 5. Now remember, if I do this right, when I take out my greatest common factor in the next pair, this should be what's left over. So we'll see. What can I take out of these two? Negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 5 is positive 20. Now, if you just took a 4 out of there, hopefully you've noticed when you got, oh, negative x plus 5. Oh, the signs are just switched, where I can take that negative out. So x minus 5, whatever they have in common, is part of my answer. And those two greatest common factors just come together to make the other part. Now again, if this would have just been x squared minus 4 or 9x squared minus 4, you still have to watch for that because you could end up having to take something else out. But again, 3 is not a perfect square. I'm not going to be able to do anything else with it. Done. So lots of little things. But again, that little to-do list that I wrote up at the top might help out. When we're looking for an inverse, remember, that just means switch x and y and solve for y. F of x is just a fancy way of saying y. So my first step is to switch the x and the y around. And now my job is to get that y isolated. I'm going to cross my fingers on this first step here. What should I do first if I'm trying to attempt to get y alone? Okay, multiply by 4. I've got to get rid of the fraction here first. So that'll just wipe that. 4x y plus 5. Subtract the 5. Get that out of there. Divide by 3. Now again, if you just leave it as a fraction like this, that's okay. Some of you say, I'm just going to go ahead and divide both parts by 3 and put it this way. That's fine too. I don't care if it's this way or this way. I'm good with it. That wouldn't be too bad. All right, number 8. Draw an example of a graph whose inverse is not a function. Okay, first question, before I can figure that out, how do I test a graph to see if its inverse is a function? What test do I use? Yeah, we're doing the horizontal line test. So I need to draw a picture of something. Doesn't matter what. Okay, I could do a parabola. Okay, I could do this squiggly. Whatever it is, so I can clearly see that when I do the horizontal line test, ultimate fail on that test. So, again, this is going to be writing how you want to as long as you get your point across. You could say it doesn't pass the horizontal line test. Maybe you say the horizontal line passes at more than 1 point, but I need to see the word horizontal line in there. Okay? And you could say this, or you could mention that it goes through more than 1 point. Either one of those is fine. But it's good to show the picture too, just so I can see that you know it's the horizontal line test that you'd be able to fail with on that one. Okay? Any issues on the front? Because I want to make sure, as we're doing this, you're seeing why. And again, it's never a bad idea if you've got access to the website at home. Maybe you print off an extra one of these, and then you can go back and go, all right, let's see if I can do this on my own now. And then you've got this the backup. You can kind of check your answers as you go too. All right, to the back. Now, we have options here. Okay, prove that f of x and g of x are inverses. Show all work. Okay? One way that you can do that is by taking the inverse of this and seeing if you get this. We've done that before. Okay? That's an option. I'll actually put that down here in a minute. Your other option is to prove that f of g and g of f both come out to x at the end. And this is kind of some good practice, so we're going to look at it this way. F of g is I have f of g of x. So when I do that, g of x is this value right here. So we're going to do some substituting. G of x is going to get replaced with its actual expression, 1/3 x plus 2. But remember, whenever we're doing anything with function notation, whatever's in the parentheses is what goes in for x. So now this becomes -3, but instead of x, this is going to go in for it. So I substitute 1/3 x plus 2 for my x and f of x. Since my function is f, it's this expression, and I take the x out and replace it with this. Now I'm just going to simplify it. -3 times -1/3 is 1. Just have x. -3 times 2 is -6. Plus 6. Those cancel out. So I just end up with x, which is a good thing. You'll see why in a second here. If I do the exact same thing, but I switch the order, so I do g of f of x, same process. replace what's in the parentheses, f of x, with its function, negative 3x plus 6. It's just a two-step substitution that we're doing. So f of x is replaced with its value. Now the g tells me I'm going to use this expression, negative 1/3. But again, whatever's in the parentheses replaces your x. Negative 3x plus 6. And then don't forget the plus 2 that's lurking there. The only thing that I've done to go from here to here is replace the x with what's in the parentheses. Little distributing, negative 1/3 times negative 3 gives me x. Negative 1/3 times 6 is negative 2. Plus 2 x, check. Remember though, you also can show that they're inverses by just doing the inverse of this and seeing if you get g of x back. Okay, that's an option. Because we've done it that way in the homework too. So either one of those will work for me. Okay? And then the rest of this basically is going to go into some review type mode. Okay, simplify. This minus in the middle, we are not boxing this out. Oh, please do not do a 3x3 box here. Leave your first set of terms alone and distribute the negative through the second set of terms. And once you're here, we're just combining like terms, and we like to put it in standard form, which is the largest exponent down to the least. Negative 5x to the third. I've got that one. I have negative 6x squared and positive 8. Positive 2. Got those. Just a single x term, so plus 7x. And negative 11 and negative 11 is not 0. 22. Standard form. I'm done. I will be back to 11 in a minute. I just want to make sure this function stuff, we're getting everything. So if I come down to 12, and I'm glad we have this opportunity to talk about 12, so we don't have a couple of the things we did on the last quiz, even though it was kind of cute. Okay, neighborhood kids want to build a tree house and they're going to have a bake sale. Their revenue from the sale of x pies is given by r of x equals 10x. Suppose the function for the cost is 4.5x plus 15. What are the pies selling for? The answer is not a tree house. $10. You're like, where's that coming from? Whatever value is in front of x for your sale, that's how much you're charging for something. So that's what we're looking for in part A. Part B, your profit function is revenue minus cost. So in other words here, it's 10x, my revenue, $10 a pie, minus the cost. Now you could leave your profit function that way, or if you simplified it by distributing 10x minus 4.5x, 5.5x minus 15. This may be easier when it comes to step C, but either of those are perfectly acceptable for your profit function. Find the profit on 50 pies. If I simplified it, now it's just 5.5. X is the number of pies, so we replace that with 50. Hearing 200. Yes. Because when I'm subtracting this whole quantity, that negative distributes to both of these. So I have negative 4.5 and negative 15 there. If I don't put the parentheses, I'd end up with 5.5x plus 15, and that'd throw me off. So I've got to make sure I distribute that negative through there. Because otherwise, yeah, I'd end up thinking I had $290 instead. That's not true. Again, when we get into the function notation, we move this up a little. Remember, state any domain restrictions. There's only a couple, but if they come, you've got to deal with that. F plus g of x. Okay, so I'm going to do f of x plus g of x. Just combining like terms, nothing fancy. It says add, I'm going to add. So x squared, there's an x. I have my constant terms. I'm done. Okay, they don't all have to be long and ridiculous. Fg of x, now I have to multiply. Now whether you FOIL here, some of you may box this. No matter which way that you do, okay, here's what I should be coming out with at the end. And again, that's foiling or boxing a 2x2 box with this. I'm done with that. That's different than this. This is now back up like what number 9 was. Now it's f of g of x. But again, what is g of x? Well, g of x is x plus 3. Okay, that's always going to be my first substitution on a composition. So now I go, okay, so the f function is this. But whenever I see x, I replace it with what's in the parentheses. So this is going to be x plus 3 squared minus 1. So I've replaced x with what's in the parentheses. And this needs to be boxed or FOILed out. This is not x squared plus 9, and that's it. Write it out as x plus 3, and FOIL it or box it. And if you do, that's what you'd end up with just for what I have in red. Then I still have to minus my 1. So that's what my composition would be. But for the little things, the little detail stuff, be careful. 16, f divided by g. Okay, so x squared minus 1, x plus 3. I cannot cancel x's, okay? These are all bonded with plus and minus. But here's my question. Are there any restrictions? What number would cause 0 in the denominator? Good. I was going to say I'm getting slightly frightened. I set my denominator to not equal 0. Okay, just the denominator. And whatever value I get when I solve that, it's all reals but that one particular one. That's what we're on the lookout for here. So if you see a fraction or a radical, alert, alert. Okay, we have to watch out for that. All the rest of them, they're all good. Slowly sneaking our way up here. Okay, find p times q of 7. In other words, what's p of 7 times q of 7? Just plug them in. Okay, p of 7. 2 times 7 is 14. Plus 3 is 17. The absolute value is still 17. Q of 7, plug it in here. So 2 times 7, that's 14. 4 minus 14 is negative 10. Just multiply them together. Even if it's a composition of functions, q of p of negative 2. Okay, if I plug in negative 2, 2 times negative 2 is negative 4, plus 3 is negative 1, but what does absolute value do? Makes it positive. So p of negative 2 is positive 1, and q of 1 just means plug in 1 for x. 2 times 1 is 2, 4 minus 2 It's 2. I'm done. Okay, so if they give you the numbers, just substitute the numbers in. Keep it simple. Sketch. Use the calculator. Type that in. It'll give you some points where you can sketch a quick graph of it. Domain never changes, just like it never has. My range, bottom to top. Well, if the arrows are going down, that's forever into negative infinity. But where's my top point? At 5. So it has a restriction. My end behavior, for my x, I always have one that's positive and one that's negative. For the positive, this is saying as my x values go to the right, so as they come this way, what's happening to my y values? They're going down, so that's negative infinity. As x approaches negative infinity, in other words, as my graph goes to the left, what's happening to y? Still going down. And then for number 11, I'll just give some of you a hint back here again. It's the only one we haven't hit up. You can either write this out and do the double box. So you box the first 2, get an answer, and then box it with the third one. Or remember, this is where you can use Pascal's triangle with that 1, 3, 3, 1 pattern, where our A's go down and then our B's go up. Okay? Either way on those. But again, I'm going to do my best to have this uploaded ASAP this afternoon. I'm going to try. We'll see how well this goes. But otherwise,